All right. Um, uh, Thank you, everyone, for being here. I'm really looking forward to share a few things that I've learned about working with mobile applications, which I'm pretty sure all of us are familiar with. But the particular thing that I want to cover right here today is about security. We're going to talk mostly about security. And full disclosure, I'm not a security expert. I'm just a software developer who kind of cares about security. And we're going to talk about security through demystifying the OWASP top 10 mobile risks, which is a mouthful. It's a mouthful to say. But today we're going to learn what OWASP is, what the top 10 mobile risk list is about, and what problem does it solve. And before we actually delve deep into the problem that this list actually solves, we need to speak a little bit about what DevSecOps is. So DevSecOps is DevSecOps and as well as its close cousin SecDevOps, which are related, is the way in which we can incorporate security into the whole DevOps process. So it's basically a collaboration framework that allows us to add security practices to the software development and delivery process. In other words, the process that we're currently doing to ship our applications have security as a central part of the development process. And when we're talking about DevSecOps, we have to talk about OWASP. OWASP is the Open Worldwide Application Security Project. It's a nonprofit that has as a goal improving the security of all types of applications, not just mobile. In fact, OWASP started as an organization that actually looked for web applications, and then they started expanding to other aspects of software development, including mobile. And it's a community-led entity that actually works to improve the security through community-led projects. And although they do a lot of things to actually preserve security standards for mobile applications, what they are mostly known for is the OWASP Mobile Top 10, which, like I mentioned before, there is a list for web, but there is also for mobile, and this is the one that we're concerned about right now. So what is the Mobile Top 10? The Mobile Top 10 is the list of the top 10 vulnerabilities that need to be looked after according to all of the experts that confirm the OWASP the OWASP standard. Like I mentioned before, it was originally envisioned for web applications, but it's more popular than ever now for mobile because of the prevalence of the mobile platform. I think we can all agree that mobile platforms are really everywhere, and you could argue that mobile security is a little bit even more important than web security. And when we're talking about the OWASP Mobile Top 10 list, this is the list that we're talking about. We're talking about 10 items that are selected periodically. This list is reviewed every few years, sometimes every year if the need arises. And basically this list encompasses all of the possible security risks that an application, that a mobile application can face. We're going to look at each one. So this list right here, this is a difference between the 2016 list and the 2024 list, just for your reference. But because we're short of time, what we're going to do is we're going to go through each one of the security vulnerabilities, and we're going to look at examples in Dart of what can trigger one of these vulnerabilities when an app is scanned through a security tool that is approved through OWASP, and more importantly, how we can prevent it. Like I said, we're gonna look at some Dart samples. At the end of the presentation, all of these samples, I'm gonna show a link where all of these samples are in a GitHub gist, where you guys can look at it in more detail. And we're gonna start with the number one, which is improper credential usage. Improper credential usage can occur when mobile apps use hard-coded credentials or when said credentials are misused. So basically, any instance of a mobile application that doesn't handle correctly any credentials within the app can trigger an M1 on a security tool. So the threat agents, like I mentioned, is hard-coded credentials, insecure credentials transmission. For example, if your application is handling credentials and it's not like sending them through a network correctly, the storage of said credentials as well, and any type of authentication that is detected as weak. And here's an example of what we mean by insecure credential handling. Like this, for a security tool, in the eyes of OWASP, is a no-no. Like using like hard-coded credentials to validate a user and a password, this will definitely trigger an M1 warning. And the way we can resolve this is basically in this example right here. We are using the Auth0 package to actually like handle the credentials in a better way. This is a good way to actually like get rid of an M1 of an M1. Prevention, like I said, avoid hard-coded credentials. If you need to store credentials, after all, try to handle and transmit them properly, like I said, using OAuth, and favor the use of authentication tokens instead of handling credentials directly. Yeah?
You haven't mentioned the biggest issue, which is reverse engineering.
Well, reverse engineering is part of another OWASP point. It's not trick.
It's the biggest risk. If you expose an Android app and it has credentials in it, if people reverse engineer.
Oh yeah, for sure. Yeah, for sure. Well, that's exactly what tools like Approved for OWASP actually do. They actually like reverse engineer the app and look for this kind of misuses. But you're right. Like reverse engineering the app is definitely one way that it should trigger this. Okay, so I'm gonna move on to the next one, and sorry if I'm going a little bit too fast. The next one is inadequate supply security chain. It's mostly associated with unsecured packages. Like for example, let's say that your app depends on a package, a Dart package that you downloaded from pub.dev, but the developer of said package is not verified, and it probably has some shady code that you don't understand very well. If a security tool from OWASP detects one of said packages, it's going to trigger an M2. The threat agents are using outdated libraries and weak code security. If your code lives in a place like GitHub, for example, these threat agents are easily avoided because GitHub automatically detects when your repository, whether it's public or private, is referencing a package version that is known to have a security vulnerability. And in some cases, it even like automates like creating a pull request for you to update the package. So this should be easy to resolve in these cases. However, you shouldn't rely on automated tools to do this. Like you as a developer, like have the responsibility to use to use trusted third-party libraries and components. Like every time that you're going to ask like a package, try to review the precedence of the package, how it works. Try to, if the package is open source, like try to go through the source code and understand what it does before adding it before shipping it to production. And and keep all of your libraries like up to date, because sometimes a vulnerability is found in a version of the library, but it's updated like in a version afterwards. And and if you keep your libraries updated, you're covered. Next one is, there's no code samples for this one because all you need to do, right, to prevent M2 is to keep your libraries updated. That's it. Next is M3, insecure authentication and authorization, which is basically the app is unable to verify the identity of its users, and if they're authorized to perform the actions that they're trying to execute. In other words, your application is not able to validate elevation in the proper way. A good example of this is similar to M1, like having a weak check about the username and a password and have it execute an elevated operation. And the way we can prevent that is, again, using OAuth and other security standards to actually validate the user's roles and provide the appropriate permissions. And in the same way, you can easily create like a Boolean function that implements a function like this one right here, like get user role, to actually like use Auth0 to actually get the role that the user needs, and then validate it properly if the user has permission or not to use this. Yep.
That's not something you do in OWASP. You should do that in your backend.
Yes, of course. Yes, of course, but let's assume that for architectural reasons, you can't use a backend. If for some reason you are forced to do this like in your mobile application, which is a totally valid way to work with your app, like M3, an M3 should be triggered. But I agree.
Aware that this is from security experts. That's a really bad recommendation because security should always be validated by backend. If you're validating your security in your mobile, I just clone your client, copy paste the code, and create a fork client.
Of course. But again, let's say that for some reason you are not able to implement that architecture, or your app like has a different way to work. Like this is the way that you can circumvent an M3. But again, you're right. Like a backend is the best way to authenticate users. Prevention, implement secure patterns for authentication. Like you mentioned, server-side authorization, use revocable tokens. Unless it's a business required and avoid offline authentication. Use the device biometrics as an additional layer of security. And yeah, this is the way that you can prevent M3. Moving on, M4, insufficient input-output validation. This is basically concerned with validating the input of your app, like making sure that any data entry that comes to your app, like it doesn't represent like a hurtful entry that can be sent to the backend and create chaos. Again, I understand that this is something that can be validated, that can be validated server side, but it's good to point it out. And a good example here is, for example, of a back practice in the mobile end. Let's say that you have a widget that is supposed to validate an email, and the only validation that it performs is that it's a valid email, and then it returns true if the validation is valid. A better way to do this, although it's also always better to do it server side as well, is to actually like implement an additional security validation. It doesn't have to be something like this, but this is just an example. Like let's say that you take like that you want to prevent your users to execute like injection SQL attacks from server side. Like this, you can just filter all these words, and this is like a more secure way to actually sanitize your input. And in prevention, like I said, sanitize user input and output data, implement data integrity checks whenever possible, and when working with databases, try to use parametricized queries. Like in the manner of possible, if you need to execute a SQL Server query, try not to execute like the SQL statement directly. Try to use parametricized queries, or better yet, store procedures on your server, and that's a better practice. Moving on to M5 in secure communication, the app connects to other devices or resources through insecure means. The usual risk of insecure communication are always about integrity, data confidentiality, and origin integrity. In other words, if the data that your app handles can be changed in transit without the change being somewhat detectable, let's say like through a man-in-the-middle attack, then that is a good example of this risk. And the most classic example of doing this is connected to insecure endpoints. Like in this example, I'm connecting to an endpoint that is not using SSL. This theoretically should be disallowed by the operating system internally. Like Android and iOS, both of them have ways in which will not allow a connection to an unsecure endpoint by default. So this theoretically would not work, but if you have this code in your application and a security tool finds it, it's going to trigger an M5, an insecure communication trigger. And the way to prevent it is obviously like instead of connecting to your API through unsecure means, you connect to it using SSL. That's basically the way you do it. Prevention always requires SSL chain verification, avoid hard coding secrets, implement OAuth or API tokens. We're seeing OAuth like come more and more, which makes us think that it's a good security practice. And consider certificate pinning. Like if you're going to be connecting like to the same endpoint all the time, consider like architecting your app in a way that certificate pinning is required for any application that is going to connect to your API. That's a good way to prevent M5. Next is M6, inadequate privacy controls, which basically means measures to obscure the identity of the user or device in a way that they are light or not existent. In other words, this particular privacy issue has to do with what we call PII, or personally identifiable information. And to give you guys a little bit more context, we do have something here in Canada that is called PIPEDA that actually regulates this for both for web and for mobile applications. So basically, PIPEDA actually defines personal information as data that on its own or combined with other pieces of data can lead to the identification of a user. It doesn't have to be necessarily sensitive information in itself, like for example, social security number. It doesn't have to be exactly that. It can be even be something like a phone number that can be reverse engineered to actually find more private information while crossing that data with other databases. So, and all of that is considered personal identifiable information. If your app is found to be mishandling personal identifiable information for a security by a security tool is going to trigger an M6. And what we know as personal identified information, this is a short list. This is not a complete list by any means, but it's a short list, a summarized list of what a personal identifiable information can entail. It entails identity, whether it's name, date of birth, signature, gender, race, familial situation, contact information, email address, telephone number, physical address, professional information like salary, your company, the company you work in, what job you have, what position do you have, any form in which a document can be identified, whether it's your ID, your password number, your social security number, your vehicle identification number, any biometric data that is associated to your health. This is very common in fitness apps and things like that. And even things that are related to like the operation of the app itself, like IP addresses, passwords, cookies, and logs. And this is an example of something that would trigger an M6 by a security tool. You can notice that in this example, we are actually logging into the console directly the username and the email and even the social insurance number. This would definitely trigger an M6. A better way to handle this is to, first of all, we're doing two things here. We are using the kdebug mode constant to actually validate that the app is running in debug mode, because you're not supposed to be logging data in production applications anyway. But let's face it, like at some point you're gonna need to debug information that will probably even tangentially touch personal identifiable information. But you should do it like in your debug environment. And even in your debug environment, you should try not to log like the most sensitive information. You can notice that in this example, we're still logging the username, we're still logging the email because we probably need it for our debugging purposes. But the social security number, we've just removed it because that's a little bit too sensitive. So yeah.
Could you compare hashes of sensitive information and use that as a comparison basis? And would that fall under security?
Sure. You could also do that. You could also in fact, this is also covered like in the last security issue, which is like insufficient cryptography. But yeah, this is something else that you could do. Prevention: don't manipulate PII only absolutely necessarily. Replace it for less critical information if possible. Like JP said, if you can anonymize it, like instead of like dealing with the actual data, hash it or do something about it so that it's not easily identified. And very important, this is not something that will necessarily trigger an M6, but if you want to comply with PIPEDA, you have to do it. You have to always provide a way for the user to delete his personal information. You always need to provide that. Next is M7. I'm going to go a little bit more faster because I'm kind of running out of time. If the app doesn't provide sufficient validation of its own binary integrity or that of this environment, this is one of the most interesting ones because this one is very easy to exploit, and it's very hard to detect. It's very hard to detect by security tools, and more often than not, you need to rely on your own methods to actually like ensure the binary protection of the app. And when we're talking about the binary protection of the app, what are we talking about? We're talking about making sure that our app has not been tampered with and that it's running on a safe environment, that is not running on a jailbroken or rooted device. This is because these are really easy ways to actually exploit a vulnerability in an app. And of some of the ways that we can actually do to prevent this is, for example, implementing checks. This is an example for an iOS application in which we actually let's say that you know in advance, of course you have to know in advance, the team ID that was used to sign your iOS application. A good idea to prevent this is to actually write a routine like this one, which actually uses the secure storage to actually look for the record of that application, retrieve the team ID, and compare it to the one that you feel is variable. If the app has been resigned, it will most likely not have the same team ID, and then you can just fail the validation. This is one way to prevent it. Another good way to prevent it is to look for known agents of jailbroken of jailbreak. For example, in this particular example, I'm looking for any of the known binaries that are associated with jailbreak agents like Cydia, Fake Carrier, Black Rain, and if any of those paths exist, then it's a pretty good indicator that maybe the binary has not been tampered with, but maybe the environment that it's running in is compromised, right? So it's not secure. You can implement an easy routine like that. That if detects that one of these paths exists, just kill the app. And another one is checking if I am running on a simulator, which also is really easy. Really easy using a package that is called Divide Info Plus. Using this package, you can easily determine if the app is running on a physical device, but just checking a property. And if that is false, then you can just also kill the app, because running the app on a simulator is another way to easily reverse engineer it. Yes.
Question. I don't understand who would report this vulnerability, because I've never seen that one.
Anyone skilled enough to actually be able to deploy the app to a simulator and have an environment on that simulator that is able to reverse engineer the app on any way. Who knows?
Because I was part of the OWASP team, so this vulnerability, any client that is meant to be portable can be run on a simulator or a compromised environment. So if you're deploying a banking app, you're asking the team to validate themselves that they're not running on a compromised environment, but that's basically it. If you consider any of our other apps, no one is going to report that. When you submit it to Android store or iOS store, no one is going to tell you you don't have sufficient binary protection. It's just a vulnerability that people report specifically for banking context.
Okay. Yeah. I mean,
Simplify vulnerabilities when you're reporting them as experts.
Yeah, for sure. And I understand, and sorry to cut you off, but we're kind of running out of time, and I have to finish the presentation. So the main thing here is that M7 is supposed to validate the integrity of the both of the application and of the environment. If a production app is running on a simulator, then you can and you're not debugging it, then you can safely say that it's probably not running on the environment that it's supposed to be running on. It's supposed to be running on a device, right? That's the main thing. You're probably right. It's probably an edge case, like a really extreme scenario, but still valid under. I feel like it's still valid under the context of M7. And we can talk a little bit more offline. For now, I'm just going to move on. In the preventions, consider obfuscation. This is particularly important if your app, maybe it's not as important in Flutter applications, but it's particularly important if your app can easily be reverse engineered through intermediate code. consider obfuscation to make it a little bit harder for an attacker to actually reverse engineer your app. Add integrity checks like the ones that I just verified on app startup and kill it immediately if any of those fail. And include automated app sign-in for your CI and CD. Next one is M8, security misconfiguration. The app's configuration settings are unsafe or insecure. Basically, this has to do with attack agents, with configuration settings on the application that are not safe for a production application. A good example of this is configuring the file provided on an Android application and just expose like the entirety of the file system just to make easier for the application to handle files. This is obviously going to trigger a warning for a security tool, and the correct way to actually handle this is to just share. You can look in the filepaths.xml file. We are just sharing like the exact path that we need the app to control, which ensures us like the app doesn't necessarily touches any file that isn't supposed to. And again, other threat agents, unnecessary permissions. So one thing that us developers, like us mobile developers, usually suffer from is to like add permissions into the app and then forget to remove them when they're no longer necessary. Let's say that an older version of Android like required the camera permission for something, and then Android was updated. That was no longer necessary, but the permission is still there, and I never remove it. I should be aware of any changes in the operating system and on the needs of the app to actually remove the permissions that I don't need. And the same applies for any unused functionality or packages. There are some packages that actually force your app to require more permission than they needed, that the app needs. But you always have to scan your app like regularly to see if this is something this is a package that you actually need, and then remove it if you don't. Always start from the least privilege principle, like default your app to the least elevated functionality whenever possible, and add the permissions that you need, like as they're actually start being necessary. Don't like provide all of the permissions at the app and then start removing it. Do it backwards. And like I said, audit the permissions of your app regularly. And M9, we're almost finishing. In secure data storages, the app stores data in security. Basically, this deals with anything that has to do with handling in an improper way things, sensitive information like credentials in the device storage. Like for example, if I do something, it might seem, some of these examples might seem like overly stupid, but these are errors that we actually sometimes like commit. So yeah, I think as something like adding a username and a password and saving it in a text file is something that I will definitely trigger on M9. A better way to do this, if you're going to handle username and password, is to use like the tools that the operating system like provides for this. Basically, password managers for Android and the iOS keychain for Apple devices, which handle all of the security concerns for you. You don't need to worry about much rather than just implement a way of actually saving your credentials securely. But if you need to do it yourself, try to do it in a way that utilizes like the functionality that the operating system has. There is a package called Flutter Secure Storage that actually lets you use the secure storage of the application, and then you can like easily like save whatever sensitive information you have. It kind of does the same that the automated process for saving credentials works on the operating system. It's just that you're doing it yourself. Prevention, always use integrated storage mechanism of the mobile OS whenever possible. Add short cache expiration whenever possible. Don't add like really overly long cache data, and keep your libraries up to date. Don't accumulate the debt. And finally, we're going to talk about insufficient cryptography. This is simply the app doesn't implement like enough cryptographic protections. So basically, if you are saving, again, another stupid example, but real world example, like if you are saving like any information in your device in a way that doesn't have like the necessary encryption, will trigger an M10. And the way to prevent it is use the packages like cartography.dart to actually like encrypt your data before storing it. And again, you shouldn't be storing it like in a file or something. You should always try to store it like in a database or something like that. Always use strong standard encryption algorithms. Try to use, if you're going to make your own encryption, try to do it using like standard encryption algorithms. Don't go ahead and reinvent the wheel, like trying to encrypt the data yourself. Use the mobile secure OS storage if you need to store encryption keys, and use KDFs if you need to do encryption. And that's all I have for today. I'm just going to recommend a couple of resources. Here's the mobile page of the mobile top 10. All of the information that I just presented to you is presented here in a lot more detail with way better examples, and a couple of books, and the code samples are available here. I know that the code presentation wasn't great, but all of the code examples are available in GitHub Gist, and you should be able like to look at all the samples in detail. And that's all for me. Thank you.